Hi everyone. So today I'm going to talk about Go module versioning evolution through today. I'm going to talk about how Go module has, the versioning system has evolved from Go 111 to 116, which is released in last February. Uh, as so little bit about myself, as I already told, I'm a software engineer at JFrog, and now I'm a gopher. You can always reach me out at my Twitter handle, Engineer Mitali B, or you can connect me with LinkedIn if you have any question about today's talk or anything about Go or anything about anything else. We can always connect. Uh, so before going further, I'm going to, whether it's virtual or it's, real meetup, we always, get excited about the swag. So as part of JFrog, we are going to give one of the Go t-shirt. So you guys can scan the code here and you will be in the raffle and one of the person will get selected and will mail the t-shirt to you. You will see this barcode at the end of my slide too. So if you don't catch it here, you can catch at that time. So let's get started. Before going further in my talk, I want to, this is a famous, I really like this saying before from Simon Sinek, which says that we say what we do as a software engineer or, any person, we say what we want to do, we get the requirements and everything. And then we come to the part how we sometimes say how we do it, how we want to implement it, or we already know how to do it. But we really say, why we do it, why, which is actually the core part. We actually thought we really don't go much deep into that or think about why we did what part is actually being done and how it is done. So in this whole presentation, which in this whole talk with each versions, I'm going to talk about what, how, and why part, like why all these things have been placed, and emphasizing more on the why part. So just to give an overview, we will be talking about Go 111 module versioning system, and then we will talk about what has been changed for pseudo versions in Go 113. And then in Go 114, what is changed related to the rendering. So if you are still using rendering, what has been changed in 114. And finally, in 116, what is there related to the module. So I'm talking a lot about, versioning and all those things, why we even need versioning. So if we think about this question, what comes to our mind? First of all, dependency management. Yeah, of course. I have a code, I'm building a code, and I have, there are a lot of libraries, especially for Go as an open source language. There are a lot of libraries, people are building around the world, and we can always use them. And even for the whether it's making connection to the database or any utilities or anything. So I need to I need to manage my dependencies. I need to see that whatever particular version of the code that is there, if I use that for over after 2 months or 3 months, it should give me the same result, and I'm able to reproduce my builds. Second is better software engineering. Software engineering happens when software developers collaborate with each other. That means they work on the same piece of code, which is not static, right? Code is evolving over the period of time. And so one software engineer who is working on one piece of code, how the other person knows that, okay, he or she is updated with the code, right? So in order to collaborate more. And also for the reproducible builds, obviously the person who is sitting here in California should be able to have the same piece of code built successfully than the person who is sitting in any other corner around the world. So it should be reproducible everywhere. So these are the main core components that we actually wanted in the versioning system in any of the languages. And so here, that's why Go has put some of the efforts to put it in place. So I'm not sure how many of you have actually worked on Go version 1.11 and before, but there was not any versioning system. That means Go tooling was not aware about how to get a particular Git tag. So whenever we do go get, it actually gets from the master. It doesn't get If we do go get, we cannot actually give a particular git tag or version that we want to get that particular version. And obviously, though there is no native dependency management system, there was not any formal dependency management. There were tools like Glide, GoDap, which were there actually to manage your dependencies, but they were not, combined with the Go tooling. So to look all these problems, to solve all these problems with Go and 11, Go has introduced the concept of module, and with the environment variable Go 111 module, it has three things, like you can put it on, you can put it auto, or you can put it off. So if you are put it in on, that means you want to run it in a module aware module system. If it is auto, that means the your project is module aware. So if you have a go.mod file and you're out of Go path, then it will work. Then it will work in module aware mode. And obviously off, that means you don't want to work in module aware mode. So I'm talking about a lot about modules. So let's go into the what, how, and why part of this. First of all, what is a what is a Go module? Go module is actually collection of packages which are in a file tree, and it has a go.mod file at its root. Now, how does the go.mod file looks like? This is a sample example. Go.mod file has a modules path at the first part. That here it's module github.com containers common. This is the full module path, and then it will have a Go version with which this particular module has been built, and then it will have a require directive. Require directive will have all your dependencies. That means module path of your dependencies. So as we know, Go uses the whole module path for the dependencies, for mentioning the dependencies. So here there is a module path for toml, and along with that there is a version. Now, Go prefers to have a semantic version as the versioning system. That means, what is semantic version? We know that it should be in the form of major.minor.patch. That means whenever there is an incompatible changes, we should bump up the major version. If there is any compatible changes, we should bump up the minor version. And if there is any bug fix for the minor version, then we should bump up the patch version. So that's how Go, and these are the release version, and these release version are being introduced in Go by tagging any version in your version control system. So that's how release version looks like. But that doesn't mean that you cannot have a pre-release version in Go. You can always define a pre-release version like this, using a hyphen at the end, and you can specify some string. So that's how whole Go module uh, go.mod file looks like, and that's how versioning are being defined for your dependencies. Now let's go to the why part. Why this versioning has been put this way, and how they are imported. So principle of module versioning for Go. Let's take an example. Suppose I'm working on a module A, and I have a dependency on module B, which has a function f1 of f1, which has a dependency on module D version 1.0.2, and I'm using that f1 function. Similarly, I'm using another. I have a dependency on another module C, which is using the same f1 function but of D, but of version 2.0.2. Now the question comes, which version of D should A refer or should A import, whether it should 1.0.2 or 2.0.1. So in order to solve this problem, Go has defined the principle which is called as semantic import versioning, which actually says the two things, that all the modules should define semantic version. That means x.y.z. And also for major version, instead of whenever you are bumping your major version, you should include in your module path, which is, so this thing is called as import compatibility rule. So that means whenever you are bumping up your version from 2 or higher, you should include that in your path. For 0 and 1, this rule doesn't follow, as 0 and 1 is basically for the test and basic release. So that means, coming back to my example, now D will have a module path for 1.0.2 as D, but for 2.0.1, D will have dv2. Now A can import both D and both D slash v2 and use both of the functions and will not have any problem. So here, that's how the major version has been put it into the place. Now going back to my mod file, if you see uh, this particular kubernetes.io klog, it is using a major version 2.4.0, and if you see version 2 is there in the module path. Now with this, there are some of the problems that has come for the developer, is that whenever you want to bump any of your dependency version from version 2 and higher, you have to change it in your go.mod file manually, and also you have to change all the import path in all of your projects. So there is a little bit pain, but for that there are some of the tools which are available, like fix import and all other things that can be used to fix all those import path quickly. And also, whenever you do go list, there is a little bit problem of discoverability of all the major versions. That means go list of go tool will not list all the major version. It will only list all the minor version under a particular major version. So the only way we can discover a major version is actually going to the source location and do a couple of curl commands to see what all major version are there for that particular source location, because the key for all the major version is that their source location will be the same. Now the major versions are being fixed, but what about minor version and patch version? Are they still fine to import? So let's take an example. I have a module A and I have a dependency on module B, which in turn have dependency on module D of version 1.3.2. Similarly, I have another module dependency of C, which in turn has dependency of D of another version 1.4.8. And I also have direct dependency on D of 1.0.2. Now, D's latest version is 1.5.0. Now, according to the most of the language, whenever this kind of situation will come, latest will get imported. That means 1.5.0. But that is not true with the Go languages. In Go, there is a principle called minimal version selection that has been introduced, that says that the module should import only the latest but not the greatest. That means the minimum version that is needed to actually build a particular module, that will get imported rather than the latest one. So here, if I see, I will not have 1.0.2 because that will be too old for A, and 1.5.0 will be too new for A. So A will import 1.4.8 of the version. So that's how the minor version of Go has been fixed and has been put into the place, and it really helps to have all the versioning system in place properly. Now let's go further. Now Go 113 has come, and it was found that there was still some discrepancies floating around because of the pseudo version. So there are some things called pseudo version that people use, and they were modifying through hand rather than Go itself to create it. And because of that, there was some problem in getting the reproducible build. So in order to to correct that, in Go 113, Go has introduced some validation for pseudo versions. So now let's go to what, how, and why part of this. First of all, what is pseudo versions? Pseudo versions is actually the versions that are actually put into place whenever we want to develop against a particular project which doesn't have any released version, or whenever we have we have dependency on any project which has not been released. So in that particular cases, developer uses pseudo versions. How does that pseudo version looks like? So they looks like this big string. If you see, it has three components. First component says the most recent tagged version in the commit graph. Second component is the commit time in UTC. And third is the prefix of commit hash generated by the underlying control version system. Now, pseudo version practically should never be typed by hand. It Go tool is aware of that, and whenever we tag any version, it automatically generate the pseudo version for you with the timestamp, with that particular timestamp. But there are some tools, or there are some outside tools, and people actually type them by hand, which was creating some discrepancy. So for example, this most recent tagged version in the pseudo version actually takes part in the minimal version selection, which I explained before. So if I modify this first part to any other, then it will actually uh, mess up the whole ordering of the system, and actually pin this particular pseudo version to your module, which might not be the latest. And also the second part, which is the commit time, that also take part in ordering of the pseudo versions. So which particular pseudo version is the latest one is being tell by is can only be tell by the timestamp. So if we change this timestamp, it again changes the whole ordering of the system. So because of all these problems, in Go 113 there were some restrictions that have been put. So now, what are those restrictions? First of all, the most recent commit graph, the whatever is the tag, it should whatever is there in the underlying version control system for the major. And second is the commit time. It should be commit time that is generated by the version control system. And third is the commit hash. It should be the same commit hash that is being generated by the Go tool. There was also other restriction, a pseudo version can have a plus incompatible suffix only if it is needed by by the corresponding major version, and if it doesn't have a go.mod file. And this is true not only for pseudo version, any other versions. And also, last but not the least, is the checksum server validation, which was enabled in Go 1 from 113. So if you see along with your go.mod file, you would have seen a file called go.sum, which actually has a cryptographic hashes or cryptographic checksums of all your module dependent module versions. And the same hashes have been stored in a checksum server. So now with Go 113, whenever we do any go get command, whatever in there in your go.sum file, the checksum is being validated against whatever is there in the checksum server. And if it doesn't matches, it will not allow you to get that particular version. So let's see how these changes have come into effect. So before 113, if you do a go get on any particular pseudo version which is actually not the correct one, and that means if you see in this example, I have actually changed the timestamp. So what it used to do, it used to get the latest for that particular major version and pin that particular module, pin that particular pseudo version in your go.mod file, which is actually the wrong pseudo version. But after Go 113, if we try to do with a wrong pseudo version, then it will give us an error saying that the maybe the timestamp doesn't matches, or the checksum is invalid, and these kind of problems, these kind of errors, we can start seeing them. Now, how to solve this if you have any invalid and not good pseudo versions? So we have to fix our pseudo versions in our direct dependencies. So if you have any in your direct dependencies, and also any in your transitive dependencies. So for direct dependencies, we can use require directive. So instead of putting the whole pseudo version, we can only put the last commit hash part. And when we run go mod tidy or go get, go tool will automatically get the correct pseudo version and pin it to your module. And similarly for transitive dependencies, we can use the replace directive instead of require. So if any of my dependencies has incorrect pseudo version, we can do the same thing, use the replace directive and use only the commit hash part, and then we can successfully build all our incorrect pseudo version in Go 113 and above. Now let's move further. Now comes Go 114. So in Go 114, uh, it was vending was given preference over the module cache. Before that, there was a module cache which was being maintained, And whatever whenever we do go get or anything, it used to refer to the module cache. But from go 114, if you define go 1.14 in your mod file, and if you enable and if you have a vendor directory, then it will always look in your vendor directory for your dependencies rather than in your module cache. Now let's go to what how and why part of vending. First of all, what is vending? Most of the people, what they do, they don't want to uh, there are many reasons actually to maintain a copy of your dependency inside project. That means whatever libraries you are using, you are having a full copy of all the code in your local, and then you build it rather than having in any central repository. This was being heavily used before Go module was introduced, but after Go module, it has subsidized it. Now let's see why we need vending. We need vending. Maybe we have a fear that uh, no. First of all, I have some of the dependency, and I want to change any code in my dependency to debug something. So the only way is that to take that particular code in my local and debug that. So for that, we can always use replace directive. We can use replace directive in our go.mod file and have that, and download that just for time being, and then debug it rather than putting it in our Git repository, the whole code of our dependency. Second is it might be possible that VCS is down. There is networking issue, or dependency might appear, especially for this open source language. There might be author who can just pull out the module and it will not be there. Or or if the dependency is using VCS other than Git, then what are the options we have? So for that, we can always use Go proxy. There is a Go proxy package. There's a public Go proxy there. We can always define in there, and we can have it cached there. Once it is cached there, it will never disappear. Also, there might be cases when we are thinking about mutability. It can change, that there is some piece of code of the same version which was there and now it is not there, it has changed. Or if we have to build without a network, there are some of the companies that doesn't allow to go outside the network. So in that case, we can use private Go proxy rather than the public one, like Artifactory. And in Artifactory, we can have both public and private modules. Now, what is the usage? Also, when we don't have all these dependencies in our local, then obviously it saves the space. And also we will have cleaner commit logs, because we will not have commit logs of all those dependencies. Obviously our whole code will shrink it down to the smaller one. So now we should think that whether we should still use the vending or not. So it's up to us. But module has since module has come, it has subsidized all these problems to use it in a better way. Now, last but not the least, recently in February, Go 116 has introduced. Before that, Go 11 module was always made to auto. That means whenever you are working in a Go language, and whenever you're working in a module, it is if you have a go.mod file, it will always work in module aware mode. But with Go 116, it will be by default be on. That means it will always be on. And there are some good features that has been coming to Go 116. Since Go 116, Go install will be using versions along with the module path. Before 116, Go install will was using always the module path. That means you can always get the latest, but not a particular version. But with Go install, we can now get a particular Git tag. So since Go install has been introduced with the version, Go get is going to get deprecated for build and install. That means now we should be using Go get only to download or build our dependencies, not to actually install them. And if you are doing that, maybe you should start moving away from it if you are using the module, and start using Go install for that. Also in Go 116, Go mod vendor and Go mod tidy will have a -e flag enabled. Uh, and there are some of the good directives that has been introduced. First is retract directive. Retract directive is nothing but whenever sometimes an author release some particular version that he or she thinks that is not good, or it has some vulnerability issue, or it has some kind of or its mod file is not good, and they don't want other people to use that particular version. So they can always use this retract directive and put that particular version with some comment like broken go.mod file. So other people will be able to see that and will not be using it, and Go tool is also aware of that. Also, there is a new feature, Go embed has come. Finally, in Go, we can use the static files, right, to embed like our HTML's file using this Go embed directive. And last but not the least is exclude directive. So exclude directive was always there before, but what it used to do, it never whatever particular version that we have defined in our exclude directive, what it used to do, it used to get the next latest version for that, and that used to break the builds. But now from Go 116 forward, it will just ignore that particular version, and it will not use any other version in replace of that. So that's how we see how Go has evolved from 111 to 116 a lot. And there's a latest surveys that says that most of the people from Go packages has moved to Go module, like 97% people. So if you have not moved, you should move it now, because from 116 module is on for auto. So that's it from my side. If there are any questions, feel free to ask me. And again, my Twitter handle is there, my LinkedIn, and there's again a code for a cool Go for t-shirt. Thank you all.